Dr. Jayashree Rane is presenting on behalf of Dr. Dilip Kulkarni, President of Sustainable Agriculture at Jain Irrigation. Unfortunately, Dr. Kulkarni, at a last-minute urgent situation, could not attend. Dr. Rane is heading Jain Irrigation's bioenergy project. She is a PhD in renewable energy engineering and is plant in charge of biogas power project.
Thank you. Good morning. I am going to share my experience of solid waste management by the way of generation of biogas and electricity. Our company is working as a food industry. We are processing foods in our plant.
They are holding it upside down.
We are processing mango as a major fruit crop. We are largest processor of mango in the world. And we are processing onion as a second largest in the world. And our brand of fruits is Farm Fresh. And both of fruit industries are generating a huge quantity of waste while processing the fruits. Besides the fruit industry, we are in other sectors also. We are manufacturer of PVC and HDPE pipes. Then we are operating in agricultural sectors also, in tissue culture and contact farming. While we are in solar business, that is solar pump manufacturing and solar panel manufacturing. And all these sectors are generating a different kind of waste. There is organic waste, plastic waste, then some mechanical scraps also is there. And our waste management urge is easily can be explained through the code given by our late chairman, that is, view this world better than you found it. So whatever the world is there, we always have to think over that it should be better, and whatever the process is going on, that should be take the step forward. So as here we are discussing about the biogas generation from the fruit waste only, because I am operating a biogas power project. As we are processing mango and banana as a major fruit crop, and both fruits are generating nearly 40% of the total waste, whatever we are processing. And our capacity is about 1,000 metric ton of mango processed on daily basis, and it is generating nearly 350 to 400 tons of solid waste on daily basis. While in our onion dehydration plant, our capacity is about 350 to 400 metric ton on daily basis, and it is generating nearly 10% of the waste. So that utilization of that waste in a common method or in a traditional method was a major challenge. Initially, we use that waste for composting, vermicomposting, but as our capacity get increased, that these methods were insufficient and creating a pollution also. So to reduce that pollution and to get eco-friendly technology, our work started according to that. For that purpose, as our fruit waste is a typical nature, having typical nature, mango waste is having very high acidity compared to banana waste. And so for that purpose, whatever fruit waste is available with us, we have taken different trials to stabilize the process or to identify the process which can be adopted for further treatment. So initially we are separated solid waste and liquid waste. That for that purpose the different trials are taken, and then biphasic system that is anaerobic followed by aerobic system is adopted for liquid treatment. So for that purpose, initially a effluent treatment plant of 2000 cubic meter capacity is installed in fruit processing plant with, and 1500 cubic meter at onion dehydration unit. This process flow can easily explain the whatever processes adopted at our fruit effluent treatment plant. Initially, there is primary collection tank, and afterwards we are equalizing that effluent for its pH and removing the solid waste, whatever is available with that effluent to reduce the plant, to reduce the COD and BOD load, and afterwards monitoring the parameter pH that material is passing through the DAF unit, so that further its COD load can be BOD and COD load can be reduced. And afterwards, anaerobic digestion followed by the aeration, or we can say aerobic digestion takes place. Here the byproduct is methane in anaerobic digestion. So that is also utilized by methane is utilized for generation of electricity. Here we can explain the anaerobic process, where initially the hydrolysis of the complex organic material takes place, which generates a simple chain acids, or we can say acetic acid with, and then afterwards these acids are utilized by methanogenic bacteria and generate a gaseous mixture having methane, carbon dioxide and moisture. And with this experience, we adopted a biphasic system, biphasic anaerobic digestion for a step forward for utilization of the solid waste into a biogas. And for that, in-house technologies are tested, and afterwards technical collaboration with some German company is also done, and for that purpose the team is formed, and company decided to establish or install a biogas plant having 1.7 megawatt capacity. This technology is specially utilized for safe disposal of food waste from food processing plant, and this plant is carbon neutral and having zero discharge system. Here easily we can understand the whole process done at our biogas power project. We had an agro industry where solid waste is generated. That solid waste we are taking to our biogas plant. Before taking that waste in our process, we are crushing that waste, and the coarse material is discarded. In case of mango stones are discarded because it is due to its hard seed coat, it is not possible for biological digestion easily. So we are discarding these mango stones, and these mango stones are used in our biomass fired boiler, or not wasted at all, but used in another mechanism. And homogeneous mixture of that material is prepared with the help of submersible mixers, and input parameters are checked, and then that slurry is taken, having 8 to 10% solid, that slurry is taken to our biogas system having biphasic system. The first phase is hydrolysis, where with the help of microorganisms, the complex organic chain organic materials are broken down into simple chain material, that is acids, and that process is progressed from 1 to 2, 2 to 3, 3 to 4 tanks. So there are 4 tanks, and according to that we are maintaining 6 days retention period in our hydrolysis tanks, and afterward that hydrolyzed material is transferred to our fermenters, where strictly anaerobic conditions are maintained, and in that conditions methanogenetic bacteria can utilize the hydrolyzed material and generate a gaseous mixture having methane 55 to 60%, then carbon dioxide 35 to 40%, and traces of hydrogen sulfide and moisture. But as hydrogen sulfide is very corrosive in nature on metal parts, before using that biogas in our generators, we have to remove that hydrogen sulfide. And for that purpose, we have adopted biological scrubbing system, where we are using thiobacillus bacterial culture, and through that culture we are countercurrent way, we are passing the gas, and during that pass, the hydrogen sulfide gets absorbed by the microorganism and converted into elemental sulfur, and gas becomes free from the H2S. Afterwards, we are condensing that gas to remove water vapors, and then that clean gas is stored temporarily in buffer balloons to match the production and utilization, and then that gas is transferred to our biogas engines for generation of electricity. These are exclusively on biogas, operated on biogas. The total capacity is about 1.7 megawatt, that is 834 kilowatt each. Two engines we are operating. And whatever electricity generated in our biogas generator, that is used as a captive consumption in our Orient dehydration plant. We are fulfilling nearly 30% of our energy requirement through that engine. And when we are operating the biogas generator, hot flue gases are generated as a process of any combustion engine. These exhaust gases are also having a temperature more than 500 degrees centigrade. So we are recovering the heat of their waste exhaust gases to run the vapor absorption chilling machine using waste heat recovery valve. And it can generate 400 tons of refrigeration. And that refrigeration is used in our Orient cold storages to cool the cold storages, and one of our photovoltaic panel manufacturing building having the supply of that refrigeration. And afterwards, when the biomethane process gets completed, mostly we are maintaining 30 days retention cycle. For 6 days in our hydrolysis tanks and 24 days in our digesters. And after 24 days, the slurry is coming out, that is whose biomethane potential get exhausted. That waste slurry is also separated for its solid and liquid part. That solid part is having a good source of plant nutrients, as whole material is coming as from the plant sources, and that is used to prepare organic manure after enriching with some other bacterial cultures. We are enriching that solids with neem cake, then rhizobium, azotobacter, and other type of bacteria. That culture is added for enhancing its nature. This is our biogas plant. You can see here the digester. There are top downs where the gas get collected, and through the pipelines we are taking out the gas. This one is our biological scrubbing unit. This is here we are using the SDP pipes for preparation of the scrubbing towers. This is in-house manufacturing was there. And this is balloon where we can store the gas for temporary phase, and then afterwards we are sending this gas through blowers to our biogas generator. And biogas generator is kept away from the production unit, nearly 800 meters away for safety purpose. This is our automation and control panel, and this is our biogas engine having Jain company. This is a waste recovery system, that is lamp is operated here for generation of refrigeration. And lastly, this is the soil conditioner, which is manufactured through the solids recovered from the waste slurry. Here we can see the silent features of this biogas plant. When we are operating the biogas plant at 70% load factor, we can generate 28 megawatt units, 28 megawatt hours electricity on a daily basis. And this Ministry of New and Renewable Energy also recognized this plant as first of its kind, because mostly the biogas plants are designed to handle single type of substrate. But here we can handle multiple type of substrate. We can handle fruit waste, we can handle vegetable waste, animal waste, and canteen waste also. And the whole system, the whole plant is fully automated and having world-class automation system. The technical know-how is taken from one German company, and the designing and installation is done by ourselves. This plant is synchronized with state grid for our captive consumption. And with the help of that solid recovered, we can generate 10 metric ton of organic manure or soil conditioner on a daily basis. This plant can easily handle 150 to 200 tons of solid waste on daily basis. But while operating this plant, there are some challenges. As this plant is based on fruit waste, the first challenge is to operate it throughout the year, because fruits are seasonal in nature. Processing is also on seasonal basis. So when the fruit waste is not available, it is a challenge to keep running the plant, because it's a biological process. We usually can't stop it or can't switch on it. And moreover, the complex organic chains, reactions, we have to control these reactions with heterogeneous material. When we receive the mango, no other fruit is processed. In mango season, we receive only mango waste. In banana season, we receive only banana waste. And in other season, we receive some papaya waste or other waste. So this is a challenge to keep the process stable throughout the year using the heterogeneous material. And for that purpose, we have to critically monitor the process parameters and to stabilize the dynamic biological process throughout the year. And for that purpose, constantly we are operating our R&D in our biotech lab in the company, so that it is easy for us to predict the future production. And this ministry given us recognition from them.